Welcome to this video, dear learners. In this video, we'll be looking at mass, weight, center of gravity, and stability. Okay, so these subtopics are very short topics under physics. Okay, so we'll start with mass and weight, and we'll see how these two are related to each other. So mass is defined as the amount of the quantity of substance in an object, while weight is defined as the attractive force exerted on an object due to gravity. Okay, so when you compare mass and weight, you'll find that the major difference here is that the mass is not affected by gravity. Okay, not affected by gravity. Okay, mass is not affected by gravity, so this means that mass is basically the same everywhere. Could be on Earth, could be on Moon. Okay, so we can say that mass is the same. Mass is the same everywhere. Okay, but then weight is affected by gravity, and this means that depending on the place, okay, it could be the Earth, the Moon, or the outer space, okay, the weight would definitely change. Okay, so the major relationship between mass and gravity is that weight and mass are direct proportional, provided the gravity which acts as a constant is constant. Okay, so we have an example here. The mass of a man is 1,200 grams. What is his weight on Earth and the Moon? Okay, so we've been given a mass which is 1,200 grams. Okay, now remember, mass is measured in kgs. Okay, so we need to find a way to convert the 1,000 grams into what? Into kg. Okay, so simply divide this by 1,000. Okay, meaning our mass would be 1.2 kilograms. Okay, so this is the mass that we need. Okay, so the question says, what is his weight on the Moon? Okay, so we need to take note of gravity. Okay, so gravity on Moon, it's simply 1.67 meter per second squared. On the Earth, the gravity is 10 meter per second squared. In outer space, the gravity is simply 0 meters per second squared. Okay, so these are known values. You just need to memorize them. Okay, the gravity on the Moon is simply 1.67. On Earth is simply 10, and on the outer space is simply what? Simply 0. Okay, so we've been given a mass of 1.2 kg. Now the question says, what is the weight on Earth? So using the formula, weight is equals to mass by gravity. This will be, the mass is 1.2 kg times the gravity. What's the gravity on the Earth? The gravity on the Earth is simply what? 10 meters per second. Okay, and when you multiply this, you get 12 newtons. Okay, simply get 12 newtons. Okay, so that is the weight on Earth. Okay, that is the weight on Earth. The question says, and on the Moon. Okay, let's find the weight on the Moon. Okay, so we say weight is equals to mass times gravity. The mass is 1.2 kg times the weight, 1.67 meters per second squared, and this will be 2.004 newtons. Okay, so this is simply the weight on the Moon. Okay, the weight on the Moon. Okay, that is the weight on the Moon. So the main thing here is to use the correct gravity. Okay, because mass is not going to change. Okay, the mass won't change anywhere. Okay, the mass is not going to change. Okay, so that's the answers for this question. Very simple and what and straightforward. straightforward. Okay, so just use the formula, know where you're calculating. Is it on Earth or is it on the moon? Okay, let's do another example. Okay, these are just simple, quite simple stuffs. So the weight of an object is 300 Newton on Earth. Find the mass on Earth. Okay, so solution. Okay, so we know the relationship between weight. Okay, the relationship between weight and mass is given by weight is equals to mass times gravity. So what we are trying to find here, we've been given the weight, we need to find the mass on Earth. Okay, so making the subject of the formula mass, we divide both sides by gravity. We cancel this, we are going to get mass is equals to weight over the gravity. What is the weight? We're told the weight is 300 newtons over the gravity. We're finding what? On Earth. The gravity on Earth is simply 10 meters per second squared. Okay, so mass will be equal to 30 kilograms. So this is the mass on Earth, and like we've said, the mass isn't going to change anywhere. So B says find the weight and mass on the moon. Okay, on the moon. Okay, the weight and mass on the moon. Okay, so that is question B. So one, let's find the weight on the moon. Okay, we know weight is equals to mass times gravity. The mass is still 30 times the gravity. Where are we calculating here on the question? On the moon, because the gravity on the moon, it is 1.67 meters per second squared. Multiply that, you get 50.1 newtons on the moon. Okay, on the moon. Then the other question in B says, we have two questions. Find the weight and mass on the moon. So what will be the mass on the moon? So mass on the moon, so remember mass doesn't change. The mass that we found here on Earth will be the same mass even on the moon. Okay, mass does not what? Mass does not change. Okay, so the last question says find the weight and mass on the outer space. Okay, on the outer space. So C, on the outer space, we know weight is equals to mass times gravity. The mass isn't changing, so it's still 30 kilograms times on the outer space. We said on the outer space, the gravity is 0 meters per second. 0 meters per second. So 0 meters per second squared, meaning the weight is simply 0 newtons. Okay, 0 newtons. So the question says again, find the weight and mass on the moon. So for the mass, nothing will change. Okay, for the mass, it will still be 30 kilogram. Okay, so this goes to show that weight is the only quantity that is being affected by gravity. Okay, weight is affected by gravity, but mass is not affected by gravity. Hence the mass is basically the same everywhere, be it on the Earth, on the moon, or in the outer space. Actually there is no gravity, since that is a vacuum. Okay, there is literally no gravity. That's why the weight will be 0 newtons. So multiply 0 times the 30, the mass, you get 0. Okay, so just to make a recap of what we've done. Okay, so we said we are looking at mass, weight. Okay, we've looked at mass and weight. Okay, so looking at mass and weight, here I said mass is the same everywhere. Mass is the same everywhere, but weight changes due to gravity. The weight changes due to gravity. Okay, the weight will change due to gravity, and that's the formula. Weight is equals to mass times gravity. So here the main thing is that the mass here is always the same. But here you can change the gravity. If it's on Earth, it is 10 meters per second squared. On the moon, 1.67 meters per second squared. And on the outer space, 0 meters per second what? Squared. Okay, so for the weight, this, because of the change in gravity, the weight will do what? Will change. Okay, but the mass, okay, it's the same. Okay, so please let me know what you think on the comment section. If you are not clear, leave a question on the comment section. I'll get back to that. Okay, so center of gravity. The center of gravity is very simple. Okay, it's really just a point through which the whole weight appears on a body. Okay, so if you had the meter rule like this, okay, 100-meter rule. Okay, if you had the 100-meter rule here, so the center of gravity is simply the point at which the whole weight of that meter rule appears to act. Okay, and if this is your meter rule, okay, you have your 0 mark here, and up to here you have your 100 mark. Okay, this will simply mean that your center of mass will be at half, which is the 50 centimeter mark. Okay, so the point or the center of gravity is simply the point on an object where the whole mass or the whole weight appears to do what? To act. Okay, so let's look at another statement, another principle called the stability. So the stability simply refers to the property of an object to regain back its original position after it has been displaced slightly. Okay, so if I have this pen, okay, so this is the pen, so if this pen was resting like this, okay, so as you can see, the pen is resting like that. So if I just like displace it, okay, even just slightly, it will fall. Okay, so just slightly, the pen does what? It does fall. Okay, now this pen cannot maintain its position. Okay, so the pen was like this. Okay, if I put it nicely, okay, this is the pen. This is its original position. Okay, now if this pen has got stability, even if I just push it slightly, it shouldn't what? It shouldn't fall. Okay, it should not fall if it has got the right amount of stability. Okay, it shouldn't fall, but it falls because this marker or the pen doesn't have what? Enough stability. Okay, but let's say I put this object here. If I push it like this, okay, it's returning to its original position. Okay, I push it like this, it still goes back to its original position. Even if I try to push on this angle, it will still come back to its what? Original position. Okay, this is because this object has got stability. Okay, this object has got what? Stability. So the ability of an object to regain its original position after it has been displaced slightly. Okay, so this whole thing is simply due to gravity. Okay, it is simply due to the center of gravity. Okay, due to the center of gravity. Okay, okay, so let's look at these two objects again. Okay, so on this side I've got my torch light. Okay, if you can see it, it has got a large base. Okay, it's resting very nicely. The pen also, the marker is resting here, but then if I just push it even a little, it will fall down. But if I push this, it's not going to fall down. Okay, it will go back to its original position. So the whole point here is the center of gravity. Okay, so this here, it has a center of gravity that is lower, somewhere here. But for this pen, the center of gravity can be somewhere here on top. Okay, so now this says that the lower the center of gravity, the more stable the body is. Okay, so if I just displace this slightly, let's look at what happens. Okay, just a bit. Have you seen? Just a bit, it falls down. It can't regain its original position. Okay, but this object here, just pushing it like this, have you seen? It's still maintains its position. It's not falling, okay? Maintains its original position because it has got a lower center of gravity and the base is large. You can see here the base area is very, very large compared to the base area of this pen. Okay, so what are we saying? We're saying that the lower the center of gravity, the more stable the body is, and also the higher, the larger the base area, the more stable the object is. So let's look at these two objects. You've got object A and B. So object A and B here. So here, the center for A, you can see here the center. Okay, so if we look at the objects here, the center of mass is center of gravity, which is also center of mass, okay? Center of gravity, here it's lower, okay? Here it's higher, okay? So we said the lower the center of gravity, the more stable. So this here has got a lower center of gravity, so this one is more stable. Okay, let's look at these two. Okay, so here if you look at here, we're comparing the base areas. Okay, the base areas. So here this one has got a lower base area. Here it has got a higher base area. Okay, so the higher the base area, the stable. So this one, it is more stable. The stable the object, right? Okay, so we have a practice question here. Why is it not advisable to put heavy luggage on a roof of a minibus? Okay, so let me know what you think is the answer for this question on the comment section.